In this video, we are going to learn about spray drying, its definition, principle and mechanism, advantages, disadvantages, and finally, a conclusion with additional examples of the process.
Instant Nespresso. Creamier, tastier milk.
Have you ever wondered how milk can be turned into milk powder that stays fresh for months? Or how fruit juices become powders for smoothies, drinks, or desserts? How do liquid eggs become convenient, shelf-stable powders for baking and ready-to-eat foods? The secret lies in an incredible food processing technique called spray drying. Spray drying is a process that converts liquids into powders while preserving their nutrients, color, and flavor. It makes foods lighter, easier to store, and more convenient to use. To understand this process, we need to explore its principle, mechanism, advantages, disadvantages, and real-life applications. The principle of spray drying is based on rapid evaporation of moisture from tiny liquid droplets using hot air. Essentially, when a liquid is broken into very fine droplets, it has a very large surface area. This allows moisture to evaporate almost instantly when exposed to hot air, leaving behind dry powder. This process combines the principles of heat transfer and mass transfer. Heat energy from the air evaporates water in the droplet, and the water vapor moves into the surrounding air, leaving dry, solid particles behind. Think of it like spraying a fine mist of water into a warm, dry room. These tiny droplets evaporate quickly, leaving no wet residue. Spray drying uses this principle, but in a controlled industrial setup, producing uniform, high-quality powders. The mechanism of spray drying can be divided into 4 main stages. First is feed preparation. The liquid feed, whether it's milk, fruit juice, or eggs, must be clean, uniform, and suitable for drying. The liquid is filtered to remove lumps or impurities, similar to how you might strain fruit juice at home to remove seeds or fibers. Then, the feed may be concentrated by removing some water to reduce the energy required for drying. It can also be preheated slightly to lower its viscosity and bring it closer to its evaporation point. Proper feed preparation ensures the final powder is uniform, free-flowing, and high quality. The next stage is atomization. The prepared liquid is broken into extremely fine droplets. This can be done using either a nozzle atomizer, which sprays liquid under high pressure like a fine mist, or a rotary atomizer, which spins the liquid on a disc to fling droplets outward, like tiny fireworks. Droplet size is critical. Smaller droplets dry faster and produce uniform powder, while larger droplets may remain wet and stick together. Think of raindrops versus mist. Big raindrops take time to evaporate, but fine mist disappears almost instantly. Spray drying takes advantage of this principle to ensure rapid, uniform drying. Once the droplets are formed, they enter a chamber filled with hot air. The temperature and airflow are carefully controlled. The hot air rapidly evaporates moisture from each droplet, leaving dry particles behind in seconds. This rapid drying helps preserve delicate components like proteins, vitamins, and natural flavors. Temperature control is crucial. If the air is too hot, nutrients can degrade. If it's too low, the powder may remain sticky or clump. Imagine the droplets as tiny balloons of liquid. The hot air instantly shrinks them into dry particles, almost like magic. After drying, the powder is separated from the air using a cyclone separator. The separator spins the air like a mini tornado, throwing the powder particles to the walls where they are collected in bins, while clean air exits the system. The collected powder is then cooled, sieved if necessary, and packaged in moisture-proof containers. This explains why milk powder and fruit powders pour so smoothly from packets without sticking. Spray drying can be done in different ways depending on the product. In co-current drying, the liquid and hot air flow in the same direction, allowing rapid drying and protecting heat-sensitive nutrients. In counter-current drying, the liquid enters from the top and hot air from the bottom, which allows better heat transfer but requires careful control. Mixed flow drying combines these approaches for optimal drying of specific products. Now let's talk about the advantages of spray drying. First, it is very fast, capable of processing large volumes of liquid quickly. The powders produced are stable and have low moisture content, which increases shelf life and reduces microbial growth. Spray-dried powders are highly soluble, dissolve quickly in water, juice, or other liquids, and retain the flavor, color, and aroma of the original product. Atomization allows for uniform particle size, which is important for mixing and consistent quality. Spray drying is also versatile, suitable for milk, fruit juices, eggs, spices, and even probiotic formulations. Powders are lightweight, convenient to package and transport, and reduce spoilage risk due to low water activity. Additionally, food scientists can control powder properties like particle size, density, and moisture content by adjusting drying parameters. However, spray drying does have some limitations. It requires high energy, making it costly to operate. The equipment is expensive and complex, so it's typically suitable only for large-scale production. Some heat-sensitive nutrients, like vitamin C or certain proteins, may degrade if drying conditions are not carefully controlled. Very thick or oily liquids are difficult to process efficiently, and certain sugars or fats can cause stickiness, sometimes requiring anti-caking agents. Overall, it is a delicate balance between process efficiency and product quality. Spray drying has numerous applications in everyday life. Milk powder is used in baby food, chocolates, bakery items, and instant drinks. Egg powder is widely used in bakeries, noodles, and ready-to-eat meals, providing convenience and safety. Fruit powders such as mango, strawberry, and tomato are used in drinks, smoothies, flavorings, and nutritional supplements. Spray drying is also applied in pharmaceuticals, stabilizing probiotics, enzymes, and other sensitive ingredients. From a scientific perspective, spray drying is a perfect combination of physics, chemistry, and engineering. It demonstrates the principles of heat and mass transfer, rapid evaporation, and particle formation. Understanding the droplet size, airflow, and temperature control is key to producing high-quality powders with maximum nutrient retention. In conclusion, spray drying is a remarkable innovation in food technology. It transforms liquids into powders that are convenient, lightweight, long-lasting, and nutrient-preserving. The next time you use milk powder, add fruit powder to a smoothie or use egg powder in baking. Remember the incredible journey the liquid underwent. From feed preparation, atomization, rapid hot air drying, to separation and collection. Spray drying is not just food processing. It's science at work, making our food safer, more convenient, and longer lasting. Truly, it is one of the most important innovations in modern food technology. Here is an example of the spray drying process in the production of milk powder.